Galileo will eventually have a 30-strong constellation of spacecraft, but for the initial IOV, the in-orbit validation phase, 4 satellites are required. 2 experimental craft, IOV-A and IOV-B, were launched respectively in December 2005 and April 2008. While securing the required frequencies, they have since been characterizing the environment of the medium Earth orbit at 23,000 kilometers and testing the critical components such as the atomic clocks and the navigation antenna. Approaching 6 years in orbit, IOV-A with a rubidium clock is still working exceptionally well, reflecting the operating margins built into the spacecraft design. In parallel, IOV-B is giving teams great satisfaction. The passive hydrogen maser at its heart is still ticking away, the most precise atomic clock ever flown in space for navigation. The IOV satellites have also been testing the ranging capabilities of the telemetry and telecommand stations, thus contributing to the qualification of the Galileo ground segment. The first 2 operational satellites in this IOV phase are those entrusted today to the Soyuz, and 2 more satellites will be orbited next year. It is a key moment for the program.
These satellites are really operational satellites that will be able to perform the operational task of Galileo, I mean receiving a signal from the ground segment and retransmitting in an end-to-end approach that really provide a real navigation signal for users.
Today's satellites and the next pair were designed by EADS Astrium and assembled in Rome by Thales Alenia Space. Each weighs in at some 700 kilograms and will span 14 meters with its solar panels deployed. The in-orbit validation phase will open the road to the full deployment capacity of the Galileo system, passing from theory to practice, so as to offer positioning services in Europe and beyond, and ensuring that Europe masters this promising field of satellite navigation.